The experiment name is determination of efficiency of bucket elevator and screw conveyor. First we are going to see about the screw conveyor. This is a screw conveyor equipment. It consists of a feed hopper, a cylinder which contains a shaft with a screw and a dispensable outlet area. The shaft will be connected to a belt through a motor, a motor through a belt for the rotating purpose of the screw. First we have to feed the grain inside the feed hopper. Then using a stopwatch we have to measure the time from starting to the dispensable disposal of full grain feeded in the feed hopper. Then we have to measure the rotating speed of the shaft inside the cylinder. For that we can use a tachometer for measuring the speed of the shaft. Then we have to measure the parameters for the diameter of a screw, diameter of a shaft, pitch of the screw and speed of the shaft, where we can measure that with the tachometer. For pitch of the screw, we have to measure the length from one blade, center of the one blade to the next center of the nearby blade. This length is called as a pitch of the screw, and this is the entire shaft. After measuring this, we can go for a calculation. The calculation part for a screw conveyor is we have to find the conveying efficiency. For conveying efficiency, we have formula which is equal to actual capacity divided by theoretical capacity into 100. The parameters such as diameter of a screw, diameter of a shaft, speed of the screw, pitch of the screw, we have to measure these parameters from the screw conveyor. Then we have to weigh the quantity of the grain which we feeded in the feed hopper, and time taken indicates the time taken to travel from the feed hopper to the end of the discharge part. Then for actual capacity is equal to weight divided by time taken, the quantity of the grain collected in the discharge part divided by the time taken to the for the travel. Then volume of the conveyor. Here for pi and r square h, for r square we are going to take diameter of the shaft, and for height we are going to take the height of the shaft from between the cylinder, within the cylinder, screw conveyor cylinder. Then bulk density, which is equal to mass by volume. Here mass will be considered as 1. As we are taking a whole grain, we can consider mass as a 1 divided by the volume calculated above. For the theoretical capacity, the formula is pi divided by 4, which is into d square minus small d square into p into w by 10 power 6 into n into 60. D square which is nothing but a diameter of a screw and diameter of a shaft, and p is nothing but a pitch of the screw, w is bulk density, n is a speed of the screw which we can measure through a tachometer. From this we can identify the theoretical capacity of the screw conveyor. As we already find actual capacity of the conveyor, we can find the conveying efficiency by using the formula actual capacity divided by theoretical capacity into 100%, which can be converted into percentage. This is bucket elevator equipment. We are going to find the efficiency of this bucket elevator. The bucket elevator contains a bucket which will be attached in a belt that will be rotated by using a motor. It is connected to a shaft which continuously gets rotated. We are going to feed our sample here. It will collect it in a bucket. There is an opening here. They are going to collect it in this bucket. Afterwards, after rotating it, the outcome will be, the output will be come from this side. Uh, the output will be come from, stop it. The, as you see that the white color is the bucket will be which is attached through a chain. The chain will rotate from the motor that is present in here. After pouring feeding the sample that side, it will collect it. We can collect the output grains from here. We have to attach a cover or a cloth. From that we can get the output. That's for calculation of bucket elevator efficiency, first we have to measure the volume of each cups. As we shown in a video, the cup of the volume of the cup should be measured, which can be obtained from L into B into H. Then distance between the two cups, we have to measure with an inch tape. Inch tape between the distance between the two cups, and then speed of the rotation, which we can be identify using a tachometer, and then diameter of the pulley, which is used to rotate the chain where the buckets are attached, and the radius of the pulley. Then weight of the grain taken for the experiment, and time taken to complete the whole experiment. Then we have to calculate the velocity, which is obtained from pi into d into n divided by 100. D is nothing but your diameter of pulley, and n is nothing but your speed of the rotation. And then we have to find the bulk density, which is obtained from mass divided by volume. Volume, we can identify volume from here, and we already identify the mass, so we can identify the bulk density. And then we have for actual efficiency, we have to calculate actual capacity and theoretical capacity. For actual capacity, we just using weight of the sample taken and divided by the time taken for the whole grain whole process to be completed. From this we can identify the actual capacity, and then threshing capacity, theoretical capacity. The formula is pi into r into w into v divided by distance between the two cups. Or r is radius of the pulley, or w is bulk density, v is velocity. From this we can identify theoretical capacity. After identifying these two parameters, we can simply identify the efficiency of the bucket elevator. That's it. Thank you.